Hello everyone. Today we are discussing uh, the most important questions on chapter electricity. Um, See, electricity chapter is very important, as well as the numericals that comes are very tricky. So I hope these these hard questions, will help you in your upcoming exams. Now we start with the first question. The diagram shows three 20 ohm resistors R1, R2, and R3, and the switch S connected to DC power supply. When switch S is open, the potential difference across R3 is 9 volts. What is the potential across R3 when switch S is closed? So when switch S is open, the current will move from R2 and R3, and it will reach to the other terminal. The current will not go to the R1 resistor because the switch is open. Now, this is the path the current follows. They have already said that the potential across R3 is 9 volts. Now, if you see, the resistors are equal, resistance is equal. So we can also say that the same potential will be there across R2. See, this is a very special case because the potential generally in series, they are not equal. In parallel, the potentials is equal, but in series, it is only equal when the resistance is equal. So this is the potential across R2 is also 9 volts. So if we can say that the total potential of the battery is 9 plus 9, which is 18 volts. Now, they said that when the switch S is closed, the resistance changes. Now, when the resistance changes, the current also changes. So first, let's find the resistance of this parallel combination. R1 and R2 are in parallel. R1 and R2 becomes parallel. When switch S is closed, so this will give you 1 upon R1 plus 1 upon R2, which gives you 1 upon 20 plus 1 upon 20. This is 2 upon 20, and the combined resistance of R1 and R2 is 10 ohm, which is in series with R3. That will give you 10 plus 20, which is 30 ohms. So total resistance total is equal to 30 ohm. If the resistance is 30 ohm, we can find the current. So current total will be equal to voltage V by R total, and this gives you 18 divided by 30, which is 6, and this is 0.6 ampere. So current is 0.6 ampere. Now in this, we can say that if the total current flowing through the circuit is 0.6 ampere, so the same current will flow through R3, because finally it is the current divides in R1 and R2, and then it moves to R3. So 0.6 ampere current flows through R3. So what is the potential across R3 now? V is equals to IR, I into R3, which is 0.6 into R3 which is 20, which gives you 12 volts. So the potential across R3 is 12 volts. Next question is, the diagram shows the circuit for a potential difference, and this is potential divider, and which now we have to find out which equation is used to calculate V1. Now we can say that the total voltage of the battery is V1 plus V2. Now if the total voltage is V1 plus V2, the total resistance is equal to R1 plus R2, because both of them are in series. So current total, if you can calculate, is equal to V1 plus V2 divided by R1 plus R2. Now, in this case, we have to find out the value of V1 in terms of V2, R1 and R2. So basically we have to find the potential across R1. So potential across R1 will be potential across R1 V1, which is V1 equal to current, the total current, because the same current will flow through R2 and R1. So I total into R1. I total is equal to V1 plus V2 divided by R1 plus R2 into R1. This is equals to V1. Now, if you multiply this here, V1 R1 plus V1 R2 is equal to V1, this V1 into R1 plus V2 into R1. Now, here we have V1 and R1 same. So V1 comes out to be V1 equals to V2 R1 upon R2. So you can check the correct option here, which is V2 R1 upon R2, which is the B option. Next question here we have is, a cell is connected to a parallel combination of a 2 ohm resistor and a 4 ohm resistor. The current in the 4 ohm resistor is 1 ampere. So which means that the current flowing through 4 ohm resistor is 1 ampere, and there'll be some current flowing through it as well. Let's suppose this is I1, and there'll be total current which is equal to I1 plus 1. Now, since 2 ohm and 4 ohm are in parallel, the potential across both will be equal. So let's find out the potential across 4 ohm resistor. So the potential across 4 ohm resistor is V across 4 ohm resistor is 4 times current, which is 4 volts. The same potential will be across the 2 ohm resistor, which is 4 volts, because both of them are in parallel. So this is, we have to find I1. So I1 is equal to potential across 2 ohm, which is 4 volt, divided by 2. This gives you 2 ampere. This is the 2 ampere current. Now the total current, as I said, total current is I1 plus 1. So I1 is, we calculated I1 as 2 plus 1, which is equals to 3 ampere. This is how you will calculate the value of current. So you can see here that the correct option is option number D. Now this question is based on the resistance, resistivity, length and area of a wire. So let's first write down the formula, which is resistance is equal to resistivity into L upon A. L be the length and A is the cross-sectional area. Now we have a zero point 0.6 centimeter length of a resistance wire. The diameter of 0.25 mm has a resistance of 6 ohm. So we have a wire whose resistance is 6 ohm, and we don't know the resistivity into length is 0.6 meters divided by the cross-sectional area is not given. They have given the diameter. So if the diameter is given, the cross-section area is mostly it is circular only. So we take a circle whose diameter is 0.25 mm. So we know that the area, cross-section area is equals to pi d square by 4. This is the area. D is the diameter of the circle. So we can write down pi into d square, which is equal to 0.25, and let's convert this in meter only into 10 to the power of, so 1 meter has how many mm's? 1 meter has 10 to the power of 3 mm. So 1 mm is 10 to the power of minus 3 meters, the whole square, and this is multiplied by 4 here. So this is for the first wire. The second piece of resistance wire of the same material has a resistance of again 6 ohm. Same material. If the material is same, the resistivity remains constant. So resistivity is rho only into the length. I think we have to find the length, and similarly we have the cross-sectional area of the diameter pi into 0.5 into 10 to the power of minus 3 meter square into 4. This is the second equation. We have to find the value of x, which is the length of the second wire. So if you divide these two, if you divide these two, divide 1 and 2, or you can use like substitution method, any method you can use, but I find this method very convenient, so I'm using this method. When you divide this cancels out, resistivity also cancels out, pi cancels out, 4 cancelled out. Now this basically what remains is 1 upon 1 is equal to, now this is 0.6 divided by 0.25 the whole square. Also this and this gets cancelled out, so what remains is 0.25 the whole square, and this is multiplied by x, and this is 0.5 the whole square. So we know this is 4 times, because 0.25 into 2 times is 5, so this is 4 times. Now x is equal to 0.6 times 4, which is equal to 2.4 meters. So you can see that there is an option which is 2.4 meters. Now, next question is a question from magnetism chapter, but most of the concept is electricity, so I have included this question as well. Now, two transformers P and Q each have 2000 turns on their primary coils and 1000 turns on their secondary coils. Both transformers are 100% efficient, so there is no loss. The secondary of transformer P is connected to the primary of transformer Q. Q provides a motor with a current of 0.2 ampere. What is the current being supplied to the primary of transformer P? So the arrangement, let's first understand the arrangement here. This is the first transformer or transformer P, and this is the second transformer, transformer Q. Now, they said that there are 2000 turns on their primary coil, so 2000 turns, and both of them has 2000 turns, and they have 1000 turns on their secondary coil, so 1000 turns, 1000 turns on their secondary coil. So this is primary, this is secondary, this is primary, this is secondary, and these are connected, right? So now they also said that Q provides a motor with a current of 0.2. So this is connected to a motor and it is giving a current of 0.2 ampere. Now this is 2000 turns, this is 1000 turns, this is 2000 turns, and this is 1000 turns. Now we should know this important formula. Np upon Ns is equals to Vp upon Vs. This is equals to Is upon Ip. Now what is it? This is number of turns in the primary coil divided by the number of turns in the secondary coil. This ratio is equal to voltage of primary divided by voltage of secondary, and this is equals to current in secondary divided by current in primary. This is very important formula, and this formula will be used twice in this process because they have given the current in secondary. The current in secondary is 0.2, so we will find the current in primary. The same current in primary is being supplied by the secondary of the P transformer, and from this we will find the current in the primary of P. So let's find at Q what is happening at Q. So Np upon Ns, we don't need potential, so we can ignore the middle ratio. This is Is upon Ip. Primary is 2000, this is for Q, divided by 1000, and secondary they have given 0.2, and Ip, we need to find the current in primary. So this comes out to be 0.1. So Ip at Q is 0.1 ampere. So the current here is 0.1 ampere. Now that's the same current in secondary of P. So we have to find the current in primary P. This is again we will do at P. This is Np upon Ns is equal to Is upon Ip. Np for P is also 2000 upon Ns is 1000. This is equal to Is secondary we have already given 0.1, and we need to find Ip. This is 1000. This is divided, so this becomes 2. So Ip is equal to 0.1 divided by 2, which is 0.05 ampere. So this is how you will find the value of current in the primary coil of transformer P. So option D is correct. I hope you have understood the questions. These are very, very important questions. Do follow and subscribe. Thank you.